Hey, very good morning, students. Let us start with the other new topic called sequence generator. You may get a question like this: design a finite state machine for sequence generator, or you may get a question like this: design a finite state machine to generate a sequence of 10110. The sequence 10110 or any random sequence will be given. I've taken an example 10110. Okay, let us see how to design a FSM to generate a sequence of 10110. It's a very important question. So first, what is that we need to do? To generate a sequence generator, what we need to do is first we need to write the sequence given in the question. So what is the sequence given in the question? 10110. So I have written the sequence 10110. After writing the sequence, you need to identify the flip-flops. How many flip-flops I need to generate this sequence generator? This is given with the formula. L should be less than or equal to 2 power n minus 1, whereas L is the length of the sequence, n is the flip-flop. So first find the length of the sequence. So go to the sequence and see the length. 1, 2, 3, 4, 5. So number of bits are equal to 5. 1, 2, 3, 4, 5. So length L is 5. Okay. Length should be less than or equal to what? 2 power n minus 1. So n is the number of flip-flops. Bring this minus 1 to this side. So it is 5 plus 1 less than equal to 2 power n. So 5 plus 1 is 6. 6 must be less than or equal to 2 power n. If I assume n to be 2, it is 6 is less than equal to 2 power 2 is 4. 6 is greater than 4. So make this n value 3. 2 power 3 is 8. 2 2s are 4. 4 2s are 8. So 6 is less than equal to 8? Yes. So n value should be what? 3. So first write the sequence. Sequence is 10110. This is the sequence given in the question. Then identify number of flip-flops required to generate this sequence. So to identify that, we need to have a formula. L must be less than or equal to 2 power n minus 1. L is the length of the sequence. 1, 2, 3, 4, 5. 5 should be less than or equal to 2 power n minus 1. So value of n is computed to be 3. It means we need how many flip-flops? 3 flip-flops. So I have taken 3 flip-flops A, B, C. Done. Now what is my sequence? First flip-flop A will have the complete sequence. What is my sequence? 1, 0, 1, 1, 0. 1, 0, 1, 1, 0. I'm done with this. Now what is that I need to do? I need to move the bits of first flip-flop to second flip-flop. I need to move what? The bits of first flip-flop to second flip-flop. This will be shifted with 1 bit delay. So there will be 1 bit. Can you see the space is empty? 1 bit delay, it will be moved. So 1 is moved, shifted to B. 0 is shifted. 1 is shifted. 1 is shifted back. Now since this place is empty, the 0 which is in the bottom will come up and sit here. Okay. Now can you see the sequence? This is 10110. How we shifted the bits of A to B? With 1 bit delay. So first position will come to second position. 0, 1, 1. After completing this, the 0 here will go and sit in the top. Can you see 0 will go and sit in the top. Now what is that I need to do? I need to shift the bits from B to C with 1 bit delay. So how will I shift the bits from B to C? These are the bits of B. I have to shift it to C with 1 bit delay. So 0, 1, 0, 1. The last bit will go and take this position. Clear? So last bit is 1. Since it goes and takes this position, this will be 1. So I have given all the data. 3 flip-flops. All the flip-flops are filled with the data. Now I need to check is the states are repeating or not. Can you see 101? Is it repeating? 101? No. 101, yes. The state is repeating. 101 is repeating. Check with others. 010, is it repeating? No. 101, yes, it is repeating here. 110, is it repeating? No. 011, repeating? No. So what is the state which is repeating? 101. So put a dash at 101. 101 is repeating, put a dash at 101, indicating that the state is repeating. Whenever there is one repeat, when a state is repeated, for that particular state we need to add extra flip-flop. So initially we know that we need to have how many flip-flops? 3 flip-flops. Can you see from this formula we have computed how many flip-flops we need? 3. That is A, B and C. After filling the A, B, C table, now since there is one state which is repeating, here the state should not get repeated. If state is repeating, then we need to add one more flip-flop. Since only one state is repeating, I am adding one flip-flop. The name of the flip-flop is D. After entering D, you need to shift the data from C to D. How will I do? With 1 bit delay. So 1 will come here, 0 will come here, 1 will come here, 0 will come here. This 1 will go and sit in the place of D. Clear? Have we done this? Yes. Can you see how the data is shifted? First you need to write the sequence 10110. Just shift the bit 1 bit delay. 1011. This 0 will come and sit here. Now 0101. This 1 will come and sit here. 1010. This 1 will go and sit here. I have done with all this. Now check is the states are repeating. 1011. Is it repeating? No. 0101. Is it repeating? No. 1010. Is it repeating? No. 1101. Repeating? No. 0110. Is it repeating? No. So since no states are repeating, we will not have any more flip-flop. Clear? Now you need to write the final output F, feedback. So final output is feedback. So again, how will I fill it? Since I have done with A, B, C, D, my final feedback I have to write. Again, same process. What process? Shift the bit 1 bit delay. So it is 1, 1, 0, 1. The last 0 should go and sit at the top. After filling this, now you need to compute the value for F, feedback. So I need to use minimization table and compute the value for feedback. How will I compute the value for feedback? How many inputs? A, B, C, D. So 4 variable came up. A, B, C, D. So what is if A and B are 1, 0, C and D are 1, 1. A and B are 1, 0, C and D are 1, 1, 1, 0, 1, 1. What is the value of F? 0. So 1, 0, 1, 1. What is the value of F? 0. Okay. Now let us see this. A and B are 0, 1. A and B are 0, 1. C and D are 1, 0. C and D are 1, 0. What is the value I need to write? 1, 0, 0, 1. It is 1. So fill 0, 1, 1, 0 according to the values in the K map. After filling it, fill all others with what? Don't guess. Now start doing the grouping. Where are the ones? Can you see? 1 is here. So what can I do? I can group this to a single octet, right? So this is one single octet. First group. What is the next possibility? Next one is sitting here. So what I can do? So I can wrap this. I can say this 4 and this 4 will form my second octet. So there are 2 octets. One is this one. Other one is lower half and upper half. So this is second octet. Clear? So what is the answer for first octet? This group, what is the answer for the first octet? This group, A bar, B bar, A bar, B. So A bar is common. So I write A bar. What is the answer for lower half and upper half? What is the answer? 0, 0, 1, 0. So 0, 0 means what? C bar, D bar. And lower half, C, D bar. So what is common? D bar is common. So it is A bar plus D bar. How you got A bar? For this first group you got A bar. How? A bar, B bar, A bar, B, A bar is common. So it is A bar. For lower this half and this half you get D bar. So what is the answer for feedback? A bar plus B bar, D bar. Now draw that. Now this is the truth table. You got the F value. F value is A bar plus D bar. So how many flip-flops you need? A, B, C, D. So A flip-flop, B flip-flop, C flip-flop, D flip-flop. What type of flip-flop I am going to use? D. Data flip-flop. So DA, DB, DC, DD. Done. Output of D flip-flop is, I have termed it as A because first one is A. First output is A. A. A is connected as an input of C. A bits are shifted to B. B bits are shifted to C. C bits are shifted to D. D bits are shifted to feedback. So A bits are shifted to B, right? So A output is given as the input of B flip-flop. B output is given as the input of C flip-flop. C output is given as the input of D flip-flop. D output, can you see D output is given as the input of F flip-flop. What is, sorry, F, what is feedback? Feedback is A bar plus D bar. So take that output, can you see, connected to a gate called A bar plus B bar. What should be the input? A bar. So A bar is coming as the input. What is the next input? D bar. So go to D bar, take this and connect it here. So what is the output here? F, A bar plus D bar. That should be, or F should be a feedback to what? A. So F should be connected to A. Okay. For uncommon clock is given to all the flip-flops. This is how you need to design a sequence generator. Can you see what is the sequence? 1 0 1 1 0. A will be 1, B will be 0, C will be 1, D will be 1, F will be meant as a feedback and comes here. Okay. Have you generated a sequence 1 0 1 1 and 0 through F? Clear? This is how you generate a finite state machine for a sequence 1 0 1 1 0. So since it is 4 flip-flops A B C D, I have taken A B C D flip-flop. What type of flip-flop I have taken? D is a flip-flop. Output of one flip-flop will be the from first flip-flop it has to go to second, second to third, third to fourth. From fourth it should come as a feedback. Okay, from fourth it should come as a feedback. What is the formula for feedback? A bar plus B bar, A bar plus D bar. Through AND gate it is coming back. Okay, this is how you need to design. In the exam, if they change this pattern, instead of 1 0 1 1 0, if they give 1 1 1 0 0, same procedure, in the place of 1 0 1 1 0, you have to write 1 1 1 0 0. Okay, this is the example to generate a finite state machine for generating a sequence 1 0 1 1 0.